So now we're pretty much pros at proving that triangles are congruent, so we will use our congruent triangles now. For example, in this proof, we are already given all of our sides congruent to one another. So we can right away say that our triangles are congruent by the side-side-side congruence postulate. And what's new today is that we're going to add one more step to our proofs. For example, if I wanted to say that angle A and angle D were congruent to each other, previously I wouldn't have had any reason to back up that claim because they're not vertical angles. I don't have an angle bisector or anything. But now that I've proven that those triangles are congruent to one another, that means that all of their parts are congruent. Angle A is congruent to angle D, angle B is congruent to angle E, angle C is congruent to angle F. All of the corresponding parts are congruent because that's what congruent triangles means. So I would be able to say that angle A is congruent to angle D. And I could either say by the definition of congruent triangles, or we have this new reason that says that the corresponding parts of congruent triangles are congruent to each other. And we abbreviate that Cpctc. Cpctc. Again, you can also say the definition of congruent triangles if you prefer. Triangles are congruent if and only if all of their corresponding parts are congruent. The corresponding parts of congruent triangles are congruent. All the angles and all the corresponding sides are congruent. Let's try another one. On this one, we're trying to prove that side EF is congruent to side KJ. There's not really a reason right away to say that those two lengths are the same, but I'm pretty sure that I can prove that those triangles are congruent to one another. First of all, I've already got two sets of congruent sides. I also see that this is in bow tie formation, so I'm going to be able to prove that I've got another set of angles that are congruent. Those two angle D's are congruent to one another by the vertical angles congruence theorem. That's three sets of congruent angles and sides, so I'm ready to say that the triangles are congruent to one another. I do have to be careful that I'm naming those triangles in the correct order. If I call the top one E, D, F, notice that I went from E to D first, so on the bottom I'll need to go from K to D first. And that is in side angle side formation, so that's by the side angle side congruence postulate that those triangles are congruent to one another. And now that I know that the triangles are congruent, now I can say that all of their corresponding angles are congruent and all of their corresponding sides are congruent. But really, I was just trying to prove that one set of parts was congruent. Side EF congruent to side KJ. Corresponding parts of congruent triangles are congruent to one another. And you can say definition of congruent triangles too if you would like. We're just going to do one more where we just sort of plan out a proof. I'm not going to write the whole thing down. We're given some congruent angles, and in the end, we want to prove that those two little orange triangles are congruent to one another. If you look at the orange triangles right away, we only have one set of congruent angles, and we could say that side CE was congruent to side CE, but that's about all that we'd be able to say about the little orange triangles. That's only two sets of congruent parts that are congruent, not quite enough. But if we start with those big triangles, I already have two sets of congruent angles there, and they are sharing a side. So I could prove that those big triangles are congruent by angle side angle. And then I could say that CD was congruent to CB by Cpctc, because the corresponding parts of those triangles would have to be congruent. And then when I look at my little orange triangles, I would have those angles. I would be able to say that those shared sides are congruent, like I said, but now that I know that CD and CB are congruent, then I'd be able to say that those orange triangles are congruent by side, angle, side. So that's just sort of a plan for how I could prove that those orange triangles are congruent using angle, side, angle first on the big triangles, then Cpctc, followed by some side, angle, side on the smaller set of triangles. The thing I really want to stress to you is that your proofs should always follow this formula where first you prove the triangles are congruent using one of those 5 triangle congruence theorems or postulates, and then you'll follow those congruent triangles with another set of parts congruent by Cpctc. That's the formula that you'll always see. Congruent triangles followed by Cpctc. So always following those congruent triangles with a Cpctc. Watch for that. And we have one definition to add to our pink sheet, and that is our Cpctc, which is also known as the definition of congruent triangles. And you are welcome to use either one of those when you're using them in a proof.